Okay, so we're starting roots and powers today, and the notes are starting on day 1, and we start with the natural number. So we're going to show you, go for it, we're going to show you all the different number systems inside of the real number system, okay? The real number system for you guys in high school, this is like your universe. I'll call it the universal set. This is the biggest thing that there is. Like, you know how you go in space and there's like Jupiter and stuff like that? Mars. Well, the universe is as big as it gets. That's all we know. Well, for math in high school, the real number system is as big as it gets. There's other stuff out there, if you ever wanted to study it in university, but for us in high school, the real number system is as big as it gets. And then inside of that, there's like in space, there's planets and meteorites and stuff like that. Well, we have other things like that in math, like the naturals, the wholes, the integers, the rationals, the irrationals. Okay, and I'm going to explain those to you right now. So the natural numbers are the counting numbers. And they look like this. You have to do a squiggle bracket. And then it starts at 1. And there's an infinite amount of counting numbers, obviously. You could always think of a bigger number. As soon as you think you have the biggest number, like $1 billion, there's always a bigger number, like 1,000,000,001. So this dot 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 tells you it goes on into infinity. Okay? So I'll just jot that in for you. Infinity. And then the squiggly bracket, this is the set. This denotes the set. And all a set is a collection of objects. So say I had a box full of marbles. That's a set of marbles. So in math, a set is just a collection of objects. And in this case, it's a collection of positive counting numbers. Okay? The next is the whole numbers. It is identical to the counting numbers, except for there's a 0. So the naturals and the wholes are basically the same thing. And in university, they don't ever mention whole numbers. There's no such thing as whole numbers. It's just a high school thing in Alberta. So just need to know it for that. The integers are the whole numbers and the counting numbers, but also the negative versions as well. Okay, so those are the integers. So the integers are infinite on both sides. So you start it off with dot dot dot, and then it's -3, -2, -1, 0, 1, 2, 3, dot dot dot. Okay, so integers are just the counting numbers as well as the negative counting numbers. And then the last thing, or the last two here, are the rational and the irrational. So the rational, I'm just going to put a little note here. Any number that can be expressed as a fraction. Those are called rational. So like, what's the everyday use of the word rational? Like if I say that person's acting rational, what do I mean? How are they acting? Normal or weird? They're acting normal. They're acting normal, as you expect. And then what's irrational? How is that? That's crazy. You're acting irrational. You're acting like a donkey, probably. That's what I like to say. When my son is acting irrational, I tell him he's acting like a donkey. So irrational is weird, okay? And I'll get to that in a second. The math definition would be the exact same as above, but it cannot be expressed as a fraction. Any number that cannot be expressed as a fraction. Okay. And I won't give you like the true mathematical symbols for it. I'll just give you sort of what we need, the meat and potatoes for high school. There's things you need to look for rational and irrational. You look at the decimal. Okay? This is what you want to do. Okay? So look, these numbers on the board. What are they doing? These decimals on the board, they are repeating. Okay, so let's take any number that can be expressed as a fraction. That can be a fraction. So can we think of one? Like the one on my board here? 1/3. What happens to 1/3? It's 0.333333. Right? What does that decimal do? What's it doing? Repeats. Okay, let's look at another fraction that acts rationally. 1/2. What's the decimal for that? 0.5. What does that decimal do? Terminates. And in fact, it doesn't actually terminate. Like, there's an infinite amount of zeros to the right. So you could just think as long as it repeats, it's rational. But some of you might forget that one, so I'm not going to include that. Just go with if it repeats or terminates, then it's rational. Now let's look at a question. Stop. It stops. Good question. So if it repeats or terminates, and we're talking about the decimal, then it's rational. Now let's think of a number that can't be expressed as a fraction. Square root 2. And we'll come to realize that any non-perfect square or cube or whatever will be irrational. So you go into your calculator here and type in square root 2. Do you guys know how to find the square root button? Yeah, it's 1.414. I know that for sure. And then there's like all these random decimals. 1.414213562 ... What does this decimal do? It doesn't repeat and it doesn't terminate. So it's the exact same stuff except the opposite. So non-repeat, non-terminating, non-terminate. Got a light slip?
Oh,
Why are you late anyway?
I slept in.
Yeah, go grab a light slip. Alright. And if you ever wanted to like look up some fascinating history in math, square root 2 is famous because it drove the Greeks nuts. Because they thought the whole world, everything about the universe was rational. They thought they could explain everything with fractions. It's really bizarre culture. Like the Greeks, the Pythagoreans, there's this cult, the cult of Pythagorean. And I think that there's a story that says that the guy Pythagoras committed suicide because of root 2. So, because he couldn't find a fraction for it, and it drove him crazy. So yeah, you could always look that up on Wikipedia if you're interested. Okay, so here's a picture. This picture is going to show up on your tests. It's going to show up on your exams. Okay, so know this picture. Anything that I ever tell you to know, I always just put a star on it. Like it's going to show up on a test. So that'll show up on a test. So there's no surprises. You guys know those Russian dolls? There's like a doll within a doll within a... You open up a doll, there's another doll, and open up there's another doll? Yeah, it's like, Inception. You see Inception? A dream within a dream within a dream. So this is similar, okay? But not as cool. Actually, this is really cool. It's math. Everything's cool about math. But here's the idea. And I'll color it to show you. There's basically two sections of the real number systems. There's the irrationals, and there's the, what's that? All lonely? Yeah, they are lonely. And then there's the rationals. So there's two large sections. Okay? And you can see that here. There's the rationals and the irrationals. And those two things make up the reals. Okay? So the rationals plus the irrationals are the reals. And it's this is not the plus like you're adding numbers. This is just like and, I guess. Because you can't add sets like that. Anyways, so the irrationals are kind of just this thing on their own inside the reals. Okay? So it's like, maybe we could draw a couple arrows like this. The real number breaks into two things, basically like that. And then we leave the irrationals by themselves. On the rational side, it's like a doll within a doll, or a dream within a dream, like Inception. You guys ever see that movie? Hands up, you saw that movie. I saw it the second time, it wasn't as good. First time I was like, whoa. Anyways, if you don't know Inception, think those Russian dolls. So inside the rationals is the integers. Inside the integers is the wholes. Inside the wholes is the natural. Thank you. Okay, and you can see that here, like, look at the naturals. Okay, 1, 2, 3. Do you see how it's like starting right here? 1, 2. So then we'd say that the naturals are inside the wholes. Does that make sense? And you can see that here. The naturals are inside the wholes. And then then it says the wholes are inside the integers. So let's try to find that. See this? The wholes, 0, 1, 2, 3. Look, it's inside the integers. So it's like a set within a set. Okay? They're contained in there. They're like, yeah. And then the integers are inside the rationals. Okay? So let's think of some examples here. All non-perfect roots, like square root 2, square root 3, square root 5, square root 7. Okay? And then there's these really cool numbers that show up in math all the time. They're famous, like there's pi and there's e. And that's e you'd see if you took calculus. Everybody knows about pi. And I'm just going to say one thing about the integers. So take a look at the definition of rational. What is the definition of rational? Any number that can be expressed as a fraction. Then it says, basically right here, that the integers are inside the rationals. So I'll put a little note here on the side. All integers are rational. So in other words, all integers can be written as a fraction. So example, 5. How do you make 5 a fraction? Good. Whoever said that. 5 over 1. So every integer is a fraction? No, it's not, Mr. Lineweber. Yeah, you just put a 1 underneath. It's like a placeholder. Now it's a fraction. And all fractions are, and if you haven't made this realization, all fractions are is just an integer on top of another integer. So it's just integers with a division sign in between. Okay. Moving on. So this next page will allow you to practice your skills. And this is the type of question they're going to ask on multiple choice. So this is multiple choice question. So you can make a note of that for when you're studying. This is an example of a multiple choice. What they'll probably do is they'll give you something like that, something like this, something like this, and then maybe this, and this. Okay? So they're going to make you look at the decimal. You just have to analyze the decimal. You just have to decide whether it terminates or repeats, and that's it. Square root 4. Well, that's just 2. You guys know that? So this is a perfect root, and we'll get into that in a second. So this is an integer. All integers are rational. So what we're going to do is we're going to put the system. or the set. The set for rational is denoted by Q. And the proper way of doing this would be like this. Square root 4 is an element of Q. Now that element sign you're going to see from time to time. Right now I'm not too worried about it. It just says that square root 4 belongs to the set of all rationals. Like, this is an object inside this bag. Okay? You know how there's some marbles in here? Well, the marbles are an element of this box. Water is an element of this bottle. Peanuts and raisins are an element of this bag. Root 4 is an element of this set of all rationals. Are those new, Lizzie? Oh, okay. All right. So let's go through these quickly. 3 is rational. Okay, let's take a look at this one. Repeating or non-repeating? It looks like it's repeating, but it's non-repeating because it's 7 1 and then 7 1 1 and then 7 1 1 1. So actually there's a pattern to it, but it's not repeating. So this is an element of irrational. And to do irrational, you just do a Q with a bar on top. Three-fifths, that's a fraction. All fractions are rational. 7/3, that's a fraction. All fractions are rational. This one's scary. Type this one into your calculator. Some calculators will say error 2. What does the TI, the big one, say? Error non-real? Error, no, not error syntax. You probably typed in the subtraction sign by accident. Use the negative sign at the bottom. What does it say? Okay, so the TI will say error non-real. Okay. You cannot take the square roots of negative numbers. You might have already known that. So this value here actually does not exist in high school math. You cannot do this. So this is not even in, like, this set of real numbers. It's not even part of this. It's part of this other fascinating place called the complex world. And we're not going to be doing anything like this. So this, we just say non-real. It's called complex. Yeah. Instead of reals, they're called complex. Or imaginary. It's just what the math world calls it. 0 is rational. Pi is irrational. 3.75. What happened to that decimal? Don't care about the negative. What happens to the decimal? Terminates, so it's rational. Is it an integer? No. Integers don't have decimals. Okay, the next one. Cube root 27. Anybody know this one? Some of these should be quick, like 3. So that's an integer. So that is rational. Look at this one. Starts off random, then goes 4 5 4 5 4 5. So it repeats. So if it repeats, it's rational. Did I miss square root 8? Square root 8 is non-perfect. So this is irrational. This one here, 2 3 4 5 6 8 7. There's no repetition, no repeats. Does it terminate? Yes. See how this one goes dot 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 dot? This one didn't. This one didn't have a dot dot dot. So this one terminates. So if it terminates, it's rational. This one, there's these invisible brackets here. You have to take care of those first. It's just square root 100. Square root 100 is just 10. This is rational. All integers are rational. 100 divided by 4 is 25. Square root of 25 is 5. This is rational. So let's take a look at h. 0. 0 is rational. What else is it? Whole. What else is it? Integer. So they can belong to, if they're rational, they can belong to various sets, and you need to be able to identify that as well. Okay? And this worksheet will help you with that. And this worksheet, you'll have a question identical to this worksheet on your written response. It won't be as long. It might be like just 2 or 3 of them. But this kind of question, so before you leave today, and you're going to do this for homework, before you walk out the door, you make sure you grab this worksheet. The answers are on the back. And if you have any questions, we can talk about them tomorrow. All right. Okay, the next thing we're going to do is roots. Do you guys know what roots are? What's a root? That's kind of a weird question. What's a square? What's a cube? What's a square root? What's a cube root? Okay, let's take a look. Let's take a look at this. This whole thing is called a radical. Not like radical dude, just radical. The little 3, see how it's written smaller than everything else? You make sure when you're writing your stuff out, you write that small. It's called a superscript. It needs to be written smaller, or else I'm gonna confuse it with the coefficient. So 4 is the coefficient. It's just a number in front. 3 is called the index. It's just like an exponent. Okay? You know how it's like 5 squared? Well, 2 would be the index. In this case, it's 3. It just tells you how many times you need to repeat the factor. And then 125 is called the radicand. And I don't care about this one. You can cross that one out. There's a really funky name for that thing, and I forget it right now, and it does not matter. Note, if there's no coefficient shown, it is 1. If there's no index shown, it is 2. You know how in the English language there's these little funky rules you got to remember? Well, this is similar. So like, if I write something like this, square root 4, it means that the coefficient is 1 and the index is 2. Because it happens so often, they don't want to have to write it all the time, and it just gets cumbersome. All right. Root x means what number times itself is equal to x. Cube root x means what number itself times itself 3 times. Fourth root of x means that number 4 times, and so on. Nth root of x means the number itself multiplies by itself n times to equal x. What you need to know in this course are the powers of 2 and the powers of 3. So squares and cubes, that's all we care about. Okay? Make sure that that's made note of. You only care about squares and cubes in Math 10C. Okay? So here we go. X is the number you're going to times by itself twice or 3 times. Okay, so the first one, 0. 0 times 0 is? 0 times 0 times 0 is? All right, 1 times 1? 1 times 1 times 1? 2 times 2? 2 times 2 times 2? Oh, who said 6? 8. Okay, let's stop. Remember I asked this at the beginning of class? The cube root of 8 is? Oh, damn. The cube root of 8 is Good. The square root of 4 is? Good. All right. So what you'll come to realize is that the first column is the root. Think about a tree. Where are the roots? It's the most basic you can get. The root is the base. Like, the root is the root. And then the squares are this column, and the cubes are that column. So if I say, what is the square root? You look at this column and then find the root. If I ask you for the cube root, you look at the cube column and then find the root. All right, let's keep going. And like my 9-year-old, like he knows all these squares. So let's pump them off quick without doing the. So the next one is. Next one is. Good. Next one. Beautiful. Next one. Look at this. Oh yeah. You're making me excited. 81. Oh man. Woo! And then we're getting to the hard ones. Oh, and then the last one. Oh, good job. Anybody know 13? Oh yeah, Ramadan. Bringing it home. 14? 196. Anybody? 15? 15? 225? 16? Okay, we'll stop there. Okay, let's do the cubes. And this is where people get completely lost because they've never done this. 3 times 3 times 3. Good. 4 times 4 times 4. How do you know this? 5 times 5 times 5? Beautiful. 6 times 6 times 6? How do you know this? You're working ahead? Put the calculator away. 7 times 7 times 7. 512. Is that right? 729. This one's easy. 1,000. This one's cool. What's 11 do? Look at 121 and 13. Look at that weirdness. It always it's like a palindrome? Like race car? Spell race car backwards. Race car. The 11s always do that. It's really weird. And then 12? 1728? Isn't there like a rap song about that? Oh. Damn, I was close. 1728. It's the cube of 12. Oh my gosh. Jeez. I'm trying. All right, just, yeah. Okay. Yeah, so for cubes, like, it doesn't usually go past 1,000 if on a test, like, and then the squares usually sometimes the squares go past 12, so you gotta be careful. But you guys remember elementary school? Yeah. Do you guys remember they give you the 10 blocks and stuff? Yeah. Well, what was the flat? How much was the flat worth? Yeah, because 100 is a square. And did they ever give you cubes? Yeah. Yeah, the cube was the 1,000. Does it start to make sense now?
You blew my mind.
Yeah, and then what was there a rod?
No.
Yeah, the rod was 10, right? Yeah. And then the unit, that's 1, right? Yeah. So the 10, look at the 10. Is that a square?
No.
Is it a cube? No, right? It's just, it's a rod. All right, moving on. Okay, calculator time. You guys all have different calculators. Okay, for the cube, if you're on the TI, you hit this button. And then I think it's number 4. It's number 4. And then you can type in 27 after. Question? Sure. Yeah, come get your calculators quick. I have 4.
Chanel, you don't get one.
Chanel, Chanel, come here. All right, so this is on the TI. Okay, if you have my, if you're borrowing mine, then you gotta go, you gotta find this one here. If you're borrowing mine, it looks like this. Okay, it looks like that. And what you have to do is you have to put the index first. So in the calculator, you would put a 3 there. This is strictly on the calculator. This is not mathematically sound at all. This is just calculator. So you go 3, this button, and then you'd put 27. Like that. And it's like second exponent. Don't use that crap. Right here. So 3 second yx. 3 second yx. Okay, so to do the next one, and then like if you're having issues with calculator, let me know, we'll figure it out. Okay, the next one is a 5th root. So on the TI, you still hit the same thing, math, and then you have to, but you have to hit 5 first. So 5 has to be on your screen first. Then you hit math, and then you find this button. So then it's the same. It's the same as every other calculator. Okay, so you have to put the index in first, and then the any root, the nth root. Okay. So the next one, C. This is just, you just hit 3. That's the coefficient. Then you hit this square root button, which is common, and then you'd hit 5. Okay, and then the last one here. This one's really weird. It's just a complex question, so they're just trying to tell you there's these things called invisible brackets. So what you want to do is basically put these brackets like that. Basically, whenever you're putting anything in a calculator that's got a fraction, you always put a bracket for the numerator and a bracket for the denominator every single time. If you have a calculator like my man Jack here, where there's no such thing as brackets and it's really, you can only type in like one thing at a time, like my man Owen at the back, what you're going to do is you're just going to figure out these things like, you know you're going to borrow a calculator from me because it's hard. You have to sort of like figure out the top and then figure out the bottom. And how are you going to go 3 minus root 5? Well, hopefully you can figure that out. But basically, simplify the top, simplify the bottom, then divide, which is not a good strategy. Just borrow a calculator from me. Like the TI, the nice calculator that most people should have, you can type this in exactly how you see it on the page, and you never have issues with the calculator. Okay? Okay, this assignment, your worksheet is completely for homework, and these questions are quick. You just look at the decimal, and then is it rational or not, and you move on. Question? Yeah, you can use the washroom. Okay, so make sure you take a look at this assignment tonight. I want to start the next lesson as well. Check your locker.
It had it being LA this morning.
Go check LA. No, wait till lunch. Okay, let's go on to day 2. All right. So we're going to start with perfect squares. And we already know what the perfect squares are. It started off like 1, 4, 9, 25, and so on. Okay. So what is a perfect square? Well, let's just think geometry. What does a square look like? And then you just draw that in. That's not a square. I was just trying something. That was not a square. Delete. Oh, oh, stop it. Okay, there's a square. Boom, there's a square. Okay, so there's a square. That's what a square is. You know that. Okay, you know what a square is. Well, what's a square root? It's the length. Okay, so let me highlight these and then you can do it however you want. So the root is the length of a side of a square. And the square is the square. So the square is this. So let's put this up. The square is 9. The root is 3. Does that make sense? So if I wrote it like this, the perfect square is the number, x is the root. Okay. So just think geometry. You have the square, that's like it's almost like it is the area. The square is the area. The root is the length. Okay. Area is dimension 2. Length is dimension 1. So the square root of 36 is 6. The square root of 49 is 7. The square root of 132 is not perfect. That's for sure. Do you want to estimate it? Check this out. What's the perfect square that's closest to 132? So it's less than 144. What's it bigger than? 121. So the square root of 132 is approximately between, like if we square root these, it's between 12 and 11. So it's somewhere between 12 and 11. And it's like halfway between. It's probably like 11.5. It is. So that's estimation. You won't be expected to estimate, okay? All right. Moving on. Determine whether or not each of the following is a perfect square. If it is, determine its square root without the calculator. Well, some of these are easy, so let's do the easy ones. 4, 9, 6 down here. Oh, 0's easy. Now I'm going to make a mistake. Can everybody watch me make my mistake? Watch this. Everybody make my mistake, and that. That is bad. Any square roots of negatives are non-real, and you just don't do them. Okay? Just say non-real. Okay, and I'm just going to do a couple of these, and then we're going to move on. This one, like, just put it in your calculator. It's probably going to be like 0.3. C is the easy one? Good. What about I? Put I into your calculator. Even though it says don't use your calculator, put I into your calculator. Is it 0.3? Yeah. Because 3 is related to 9. You know that, right? And then, like, this is a tenth. So then the square of a tenth would be 100th. That's why it goes to the 100th. Don't worry too much about that. Let's try some of these that are non-perfect. Is 225 perfect? Yeah, 15. So let's try, oh geez, what did I just do? Let's try one like 19. 19 is actually quite a special number. Why is 19 special? It starts with a P. It is It's prime, yeah. So you can't take the square root of a prime. So let's take a look at this one. Square root 19. It's definitely going to be smaller than square root 25. Why did I choose 25? Because it's perfect. It's definitely bigger than square root 16. So square root 19 is smaller than 5, but bigger than 4. What's it closer to, 16 or 25? So I bet it's closer to 4. How about like 4.3? Did I get it? 4.4 after rounding. So I was close. I was close. Okay. There's going to be questions where you have to, in the homework, there's going to be like, put on a number line. So all you would have to do is just use your calculator, because I'm not going to make you do this, where I estimate. I'm not going to make you do that. But you just need to put the decimal on a number line. That's a multiple choice question. Is that going to be hard for you guys? No. So there's a free mark. Okay, let's move on. You gotta know your perfect squares. If you have the TI, you can cheat. Go to this button. If you have a TI, it's at the top left. You see it? Ooh, only on the nice graphing calculator. So if you don't have a graphing calculator, I'm sorry. You don't get to cheat. It says y equals. It's at the top left. It's up at the top. It's like there's 5 graphing buttons that you're not used to. Top left says y equals. So then you hit this button X. X is down below. It's like got a bunch of other things with it too. There's like X, T, theta. I don't know if you see that button. Can I borrow this for a sec? Hey, pass that to me. Come on, pass it. Give it to me. So after you hit y equals, you need to type this or hit this button. There's X, T, theta, N. Find that button. It's next to alpha. So you hit y equals, then you hit that button. Then you're going to hit your power button. That's the power. That's like that arrow thing. And then you hit 2. And on your screen, it should look like this. Like y1 equals x squared. And then you're going to hit second, then you're going to hit graph. Or not, yeah, graph. And what's going to happen is a table is going to pop up. And then all your squares will show up. So you get that in the y equals, and then second table. Or second graph, the table, there they are. Okay, and so guys, if you hit this button again, hit the y equals button again, hit the y equals button again, and then there's a y2 there. In y2, put x cubed, and then hit second graph again, and then all those cubes will show up. And it's totally cheating. And it's awesome. Yeah, good. Go back into y equals and do it again. X cubed back to the table by second graph. And then those are the cubes. And you can scroll down to find them all. Okay. So ladies and gentlemen, that's why we recommend that you get this, because I can show you some tricks. Yep. Yes, it's evil, but it's diabolical good, but it's amazing. Okay, let's take a look at this question here. Jackson could always borrow one. All right, let's take a look at this next question. It says a square has an area of 169 centimeters square. Okay. So let's go back to our notes. Let's go back. Did I give you guys the x squared or did I give you the x? What did I give you? Did I give you the area or did I give you the length? What did I give you there? That's the square. So draw a square. 169 goes here. 169 is the area. I gave you the square. So can we find the side length? It's the root. So you'd go like square root 169 is 13. So 13 goes there. So just be cautious, be careful. Did I give you the square or did I give you the root? Now you can answer the question. Determine the perimeter. What is perimeter? Is that the good? Is that the grass or is that the fence? The fence. So 13, 13, 13, and 13. It's just 4 13s. What's 4 13s? 2 26s. That is 52. Question. Yes. All right, the next one. Ooh, measurement. You remember this stuff from February? Early February. Surface area of a sphere is given by this formula. The surface area is 2500 pi. Determine the radius and the volume. We did this stuff. So they gave us the surface area, so we can substitute it right there. 2500 pi equals 4 pi r squared. What are we trying to solve for? Radius. Okay. So what do we do? What do we got to do? Do we subtract or do we divide? Or do we add? Or do we times? What do we do? What do you want to divide, Sydney? Good. 4 pi. Why did she do that, you guys? Isolate r. Good. Divide it on both sides. Luckily, the pi cancels. What's 2500 divided by 4? Oh my gosh. 625? Now, how do I solve for r if it's r squared? Square root it. So r is equal to the square root of 625, which is 25. And that's probably all from a calculator, right? Now I could go and find the volume. Now that I know the radius, I can go and plug it in right there and find the volume. 4/3 pi 25 cubed. And then you could find the volume. Does anybody want to just pump that off quick? $65,449.8. All right. All right. And now we'll do the perfect cube. And then I'll be done.
Does that cable go on forever?
Yes.
Because I'm at 627.
There might be like overflow error eventually. The numbers get too big. All right. I just tried to blow off this black mark on my screen. Did you guys see that? I'm losing my mind. I just tried to go like this. Okay. So, just going to erase this stuff so we still have some space. All right. Okay, perfect cube. So what's a perfect cube? Well, I don't have a nice shape tool for this, so I'm going to have to try my best. Well, I don't oh, maybe I'll use the line. No, I'll just draw it out. Okay, perfect cube would look like what? It would look like a square. Okay, there's my square. And then what you need to do is like put a square like this. Chanel, what's up? Yeah. So there's a square like that. This gives the impression of 3 dimensions when you connect like that. Okay. So the perfect cube is x cubed. The root is x. The perfect cube is the volume. The x is the side length. The root is always the side length. The cube is the volume. The square is the area. So we go x, x, x. Length, width, height. So volume of a prism, rectangular prism, is LWH. In this case, they're all x. What's x times x times x? X cubed. Okay. So the volume is the cube. Okay. The side length is the root. And you can think back to the cubes from elementary school, the 1,000 cube or whatever. It would have side length 10. If you put the 10 rod, here's the 10 rod. If you put a 10 rod this way, you get the flat, which is 100. And then if you stack 10 flats, you get the cube, right? So if you stack 10 flats on top of each other, you get the 1,000. All right, so here we go. 27 is a perfect cube. It is formed by multiplying 3 factors of 3 together. The cube root of 8 is? Good. I've asked you guys 3 times now today. The cube root of 8 is? Yeah. Sorry, I get excited about the cube roots. Cube root of 64 is? 4. Cube root of 125 is? This one's easy. It ends in a 5. 5. And this is where we will start tomorrow. Okay, so thanks for watching.